couple of years back. We had Scott Kelly grow not just vegetables, but also flowers. And here's a zinnia flowers that he grew. And he was really happy, very proud of his flowers. And actually, this has another aspect of it, the psychological effect that having this color flowers has on the astronauts. And actually, that was one thing that he mentioned, that, yeah, if anything, he was really happy of that, to have those. And as a matter of fact, one story about these flowers is that they started developing, when he started growing the flowers, they started developing mold. And mold is a really, really bad word, and we really don't want to have it in the space station. Imagine it's a closed environment, closed loop environment. You don't want to have mold, which could affect your lungs, and it could be really, really bad. So from the ground, we instructed Commander Kelly to get rid of them, to put them in bags, double bags, and throw them in the trash. But he was like, okay, well, can I just keep the ones that are still good? I'll try to save them, and just throw away the ones that are bad, and make sure that there's no mold left. And we actually kept them, and so it boosted not only the morale, but actually it helped us identify how they behave, the water regulation, water requirements, and again, the psychological aspect of it. And we've been growing plants for some time, and actually in this picture I worked with this crew from the ground, and we have these two are part of the Artemis team, and they were growing pak choi. And on the ground in mission control, we were having a lot of fun with them, and we tried to reproduce that picture that came out naturally for her. We would try to reproduce that here, and she did a pretty good job at it. But in any case, so we're learning about that. What I want to show you here is that scientists come in all different sizes. And here we have this team of scientists from Arizona, and they actually came up with an idea that how to improve you remember that I talked about fertilizing, and how to improve soil by using a plant that is known for its capability to put nitrogen back into the soil. So for them in particular, they got inspiration from the movie The Martian. I don't know if you've seen that movie, where the astronaut starts growing potatoes on Mars. So using inspiration from that movie and agriculture, they came up with this idea to grow the plant that you're going to see a little bit. And two things that I liked about this is that for her, when she was little, she would just go out in the yard and fall asleep watching the stars. And for her, it was a dream come true to actually have her experiment launch to the space station. And for this other fellow, Nicholas, for him, the most exciting part was that they actually just had an idea. They would just get together during the weekend, came up with the idea, and actually ended up launching their experiment to the space station. So, scientists, like I said, is not just these professors, universities, or medical doctors or in hospitals or research institutes. It's students, just like all of you, who can actually get your ideas, develop your ideas, and you can get them to space or whatever may be appropriate for your experiment. So for them, they had the knowledge of like I mentioned, the nitrogen cycle, and we have this plant that takes nitrogen from the atmosphere and it brings it down into the root system, where we have these bacteria that will decompose it and put it back into the soil. So using that concept, they came up with the clover plant, where these nodules here, that's where the bacteria lives. And they wanted to define if microgravity affects how the plant produces nitrogen, how effective it is when it's in space. So they got their experiment going. They launched it in orbital, and it was very successful. And apparently, the microclover is still an effective way to naturally bring nitrogen into the plant. Then a very recent, and this is very as recent as of the last couple of months, we had another investigation, and in this one, we grew chili peppers, spicy chili peppers, on the space station. This is a different system than the one that I showed you before. This is an enclosed system. It still provides everything that is required: the air circulation, the water, the light. In this particular system, the roots are automatically watered. In the previous system, the veggie system, the astronauts go in and put water themselves. So they need to monitor how the plant is doing visually, and then based on that, water the plant. In this one, it's an automated system where it measures the humidity on the environment, in the chamber, and then based on that, it waters the plants. So in this system, the first time ever that we grew all of these peppers, and actually this one is called the Advanced Plant Habitat. And again, it was really, really cool. The crew loved it. They actually ate the peppers, the chili peppers. And one of the reasons why we grew this particular plant is because in microgravity, the astronauts have said that they've mentioned that they lose some of their sense of smell and the sense of taste. So this would be good for them in that kind of situation. So, and we have a new system. This is called X-Roots. And X-Roots is a brand new experiment in the sense that it hasn't started yet. It arrived to the space station this last Saturday. So the crew still hasn't set it up, but what they're going to do is, this is a sample of what it looks on the ground. They're going to get their seeds, get them in these chambers, and then hydroponically take care of the seeds. So, and again, in this particular case, this is enclosed, the root system is enclosed, and they're going to provide the nutrients, the fertilizer, through with water and spray, instead of actually watering the system, but it's going to be a spray. So this is a brand new system. Like I said, we haven't tested it yet. It just arrived at the space station. So, but we're really looking forward to all of this. And of course, when you think about the benefits of doing this, there's benefits, of course, to having this capability to maintain and sustain astronauts in space in long duration missions, but also on the ground, these technologies, all of these systems that I've showed you about growing plants, they're very useful here on Earth as well. So in areas where the water is very limited, for example, something like this, where you spray the water, only the amount that is needed, and whatever is not used, you recycle it. So that's a very effective way to maintain and keep that resource, that valuable resource, intact, or the minimum impact. So things to consider, and all of the benefits that what we're doing in space is not only for space, but it's also for here on the ground. And you can imagine something like this in the future. And as a matter of fact, there's a company, Nanorax, that is already planning to build a separate space station, and they're going to grow vegetables. What they want to do is they are getting ready. They're aligning themselves with this growing market, commercial market in space. So they're actually going to grow vegetables in space to provide them as a resource to all of these other crew members that, when you think about it, you know, with private industry engaging so much in space, we're going to have a lot of space stations, not just one space station or 2 or 3 space stations. We're going to have several space stations around the Earth. We're going to have bases, lunar base on the Moon, eventually Mars. So this company, Nanorox, they're starting today building to get ready for that point. So, and that's the way to go. You know, get ahead of the game. Get ahead on your, like many of the projects that I've been talking to some of you. You know, you are getting ahead of the game, getting started on that, so that when the opportunity comes, you already know what to do. You're already there with the solution. So another situation is exploration, Mars exploration, going to the Moon, how to make sure that the crew members are safe, not only here, but as we go further into space. And for that, what we're doing is we're sending robots, at least for Mars and the Moon as well, sending robots before we send humans. And this is what we call the bots before boots. So we have robots today on the surface of Mars, and we're continuing sending, these robots so that they study where the humans will eventually go. So with that, I'm going to show you a video right here of Robonaut, which is a robot that has been working for many years. It can lift objects. We can send him to high-risk areas. It's been on the space station for many years. So with that, and I had an opportunity to meet that robot here at the Johnson Space Center. We're going to be using this to get to space, and actually we launched it to space, and we're still testing how it works in space. Now that was in space. That robot was made for space, but we have a different one, which is for walking on a surface. This robot, Valkyrie, NASA has been working with General Motors to develop the robot. It's got, we're working on, and the same with Robonaut, and we want to do is create these technologies that will help humans so that not only in space, but also here on the ground, where we can send robots to work in areas that are dangerous for humans, if it's a high radiation area or potential other hazards, so we can send humans. A very late, brand new, relatively brand new, actually this is the 3rd time that we're doing this competition. And these are, again, talking about robots, these are called Astro-Bees. We have 3 Astro-Bee satellites on the station. And for that, we have a Kibo Robot Programming Challenge. Make a note of this website, jaxa.krpc.jp. Right there, that's where you sign up for this competition. The competition is to program one of these robots to go and fix let me tell you the scenario. The scenario is, on the competition, is that there's a leak in the GEM module, Japanese module. So the astronauts cannot go there because it's not safe for them to go there. So they need to send a robot to fix that problem, and then come back to the astronaut and tell them, yeah, the problem is fixed. So the students are going to program the robots, and there's going to be a competition on the ground, and the winner, and it's multiple countries around the world, and the winner from each country, then they're going to go into a final session, and the final session is going to take place in the space station, where the astronauts will set up the robots, and they will run the student code from there. So if you're interested, go into this website, and it's a JAXA. JAXA is the Japanese Space Agency, and it's in collaboration with NASA. So interesting. And the last example that I'm going to show you is the 3D printing facility. But this 3D printing is a biofabrication facility. So in this particular case, we want to use 3D printers to produce usable human organs. Here in gravity, when we try to print human organs, it doesn't work because the gravity collapses those capillaries, so it doesn't work. In microgravity, they can stay used in a usable form. So we're using this to learn how to do it. And again, this is a stepping stone to manufacture human organs in space. So, and again, this has a lot of benefit, not only for humans. Let's say you're humans in Mars. They can actually, if somebody gets sick, they can fabricate a lung or kidney or whatever they need. But also, learning this, how to do it, we can actually fabricate them in space around the Earth and bring them here to the ground regularly, so that we don't have the people that need a donor, they don't have to wait for a donor to become available to have their organ, but actually they can have it fabricated using their own DNA. So this is something that, again, it has a lot of benefits, not only for space exploration, but also here on Earth. And I will leave you with that. And remember that what we're doing, you will be the ones doing all of these things, because you are the future, and the future is now, so you need to start working now on your future. And that's it. Thank you.
Thank you very much, Jorge. Just want to once again thank you for sharing some of the insight into what's currently going on at NASA in collaboration with other space agencies around the world, and just to look at some of the work, the experiments, the projects that are being done, and some of the benefits that they have, both for short and long-term space travel, but also benefits down here on Earth. So once again, thanks again, Jorge Sotomayor from NASA.
Thank you. So let's come back to our presentation, and I'm really happy to invite next speaker to the scene. Please welcome Reem Alali. Engineer Reem Alali recently graduated from the University of Dubai with a bachelor degree in electrical engineering, specializing in communication, and currently pursuing her master degree in artificial intelligence at Ajman University. She is working as a research assistant at Mohammed bin Rashid Space Center Lab on different image processing projects and remote sensing applications. So, Reem will give you some more examples on the topic and some more background on the topic. Thank you.
Hello. Good afternoon, everyone. Thank you so much for attending. Thank you, MILSET team, for organizing this amazing conference and for making us all a part of it. So I'll be talking about our future in space. Starting with UAE and Mohammed bin Rashid Space Center Agency, I'll talk about Mars 2117 strategy, and then we will go over the other future projects worldwide agencies. So starting from Mars 2117 vision. The vision is to develop a scientific and innovative technical capabilities necessary to achieve our sustainable human settlement on Mars by 2117. The mission is to prepare cadres of space scientists and engineers that can enable the UAE to contribute to the development of space travel and planetary settlement capabilities, especially in Mars. So for this project, we have 4 main pillars to serve the present on Earth and the future in space. So this is some pictures showing the Mars settlements related to what we're hoping to achieve in 2117, hopefully. There is also a virtual reality video which you can look up into and YouTube, showcasing how life would be on Mars, what's happening, all the applications and new technologies that they're showcasing in this video. So, okay. So as I mentioned, there's 4 main pillars in this project. The first pillar is research and development. So the main idea is not only going to Mars or be the first on Mars. We're trying to also get the projects and the achievements that we can accomplish in space here also on Earth. Lots of experiment and growth which can help us here now on Earth, not only in space. So starting with research and development, this is one of the main targets that we're focusing on today on Earth. So one of the main projects in this pillar is Mars Science City, which we're now trying to achieve by 2024. It will be located in Dubai Academic City. We will run Mars experiment for food, energy, and water, and testing and studying. Everything to prepare for our mission will be in the Mars Science City. It will also have robotics laboratory. It will take researchers, scientific laboratories. It will also have a museum of Mars and space science. It will also run activities for students and everyone who is interested in space sciences. It will provide eventually a scientific and technical environment for this industry in the UAE. So this is a picture of the city. It will be inshallah done by 2024. This is some of images showing the interior of the Mars Science City. This is also a picture of the museum that inshallah will be held in the Mars Science City. Another projects related to research and development that serve our Earth and ground right now in the UAE. The UAE analog mission, it will be specialized in mission simulating space-like and other plants conditions on Earth when we can try and experiment our coming project. It will prepare humans for space exploration and test new space technologies. Another project is the Emirates lunar rover, Rashid rover. It will also be launched in 2024. The main objective of the rover is to study the surface of the moon and the environmental changes due to the climate changes. It will also develop robotics and AI techniques to explore for exploration vehicle systems. This will help us more to explore the moon and the Mars in future. The final project which we're also now working on is the research sustainability in space. One of the main ideas is converting carbon dioxide into glucose project. This is an image of the rover. which will be sending to the moon, inshallah, by 2024. So moving to our second pillar, which is education. We're so focusing in education because the missions which we're proposing will be in 2117. So we need you, all the students, to get interested in this topic, because as I mentioned, it's not only focusing on space, it also serves our now being time, and it serves the projects in our humanity, it serves water security, food security, lots of matters in the earth. So we want you guys to get interested in this industry and get more involved in space projects. So in the education, we're arranging lots of space activities to serve our mission for Mars. We have space explorer camp, summer camps, space science, spring camps, innovation week, scientific club, and annual space festival, which will get the students more involved in what we'll be doing, inshallah. The third pillar is enablement. So there's two main projects. MBRC lab at University of Dubai, which I am working in currently. It has technical and scientific laboratory, which enable different authorities in the country to develop technologies and conduct advanced scientific research. So lots of organizations within the UAE are asking us and the MBRC to develop some projects related to the ground. So as I said, it's not only about the space, it's very related to the earth. Another gesture in the enablers is the Space Venture Program. It encourages the establishment of local and national companies to work in the space field through a program that aims to provide financial support and technical advice to serve the development of the local space industry. As Mr. Jorge said, there's lots of companies, private companies are working in this field right now, and here in the UAE we're also encouraging that through the Space Venture Program. Finally, in the collaboration, since we're aiming to reach Mars by 2117, we aim to collaborate with lots of space agencies worldwide. So one of the main projects in this section is the World Space Sustainability Association. It is the establishment of a global association based in the UAE to unify global efforts to sustain space. So it's basically where lots of sustainability proposals are there, just to gather all the information, how can we survive in space using sustainable resources. It also provides recommendations and proposals to achieve sustainability standards in space, as I mentioned. Okay, so this is basically what I mentioned is all serving 2117 Mars mission and the UAE. And now I'll go on some of the future missions worldwide, starting with humans on Mars, as my colleague Mr. Jorge mentioned. The nearest suspected mission will be in the middle of 2030s. It will be by NASA. They will have potential human habitats. They are also planning to produce bricks from pressurized Martian soil for future colonization. As he mentioned also, they're trying to grow plants for space food on Mars space. This is a picture of the initial human habitats on Mars. So Mars colonization, the nearest expected mission will be around 2040s. It will be by NASA, ESA, SpaceX, and other organizations. Scientists will settle initially to study the planet Mars, and then average citizens later on will move into living on Mars permanently. They are also trying to build a Mars colonial transporter. It can transport 100 people at a time from the Earth to Mars. As you can see here, the proposed Mars colonial transporter, and this is what we hope to see on Mars. So moving to humans on the moon, The nearest expected mission around 2025, it will be by NASA. As he mentioned also, they will send the first female astronaut on the moon. They will try to set for a moon base camp, and then they will conduct some lunar exploration, and they're also trying to build a moon lander for future uses. This is a picture of the proposed moon lander, and this is the initial moon camp. Okay, so moon base camp, they are trying to propose it and achieve it by 2030, as I said, by NASA. It would support moon future missions in the long term. It will include a modern lunar cabin, a rover, and a mobile home to help them to run experiments and move on the moon. They will start harvesting lunar resources, and they will conduct lunar discoveries and scientific researches. This is an example of how the moon base would look like with the solar panels and power systems. Moving to other space future project, which is the Titan submarine. They're expecting to launch it around 2040s, also by NASA. It's basically a submarine which they will send in the sea. In the Titan, it will study the chemical composition of the liquid of the Titan largest northern sea, Kraken Mare. It will study the surface and subsurface. It will investigate the mixing of the layers in water. It will cover wind, waves, and the bottom composition of the Titan. The Titan. This is the proposed submarine. One of the hot topics right now is space tourism. There is two kinds of space tourism: the suborbital space flights and the orbital space flights. In 2022, Virgin Galactic, it's all over the news right now that they're proposing this flight. It's a 90-minute flight. It has a speed of 4,000 kilometers per hour. It can carry 4 passengers and 2 cabin crews, and it costs $450,000 for each passenger, and it can reach up to an altitude of 110 kilometers. They actually ran a test flight, and it was successful, and they landed successfully. So this is the space from inside. So moving to the orbital space flights, they actually conducted a one in 2021. It was by SpaceX, the Inspiration 4 mission. It was a 3-day flight. It has a speed of 300,000 kilometers per hour. It had 4 passengers, and all of them were civilians, no astronauts. It costed $55 million for each, and it reaches an altitude of 584 kilometers. This was the flight, and this is the landing. Moving to the space hotel, in future we will have a space hotel. It will accommodate 280 guests and 112 crew members. It will be assembled by Orbital Assembly Corporation, and it will be called Voyager Station. It has an artificial gravity, and it will be located at 1,900 kilometers above the ground, and the price will be $5 million for 3.5 days stay. It has lots of facilities, suites, restaurants, entertainment center, gym activities, and luxury villas. This is the image of the proposed Voyager station, what it has. So finally, where you all should be focusing on right now is the space future technologies. This is a list of the technologies which they're already working on right now and trying to achieve. Advanced robots. They're also trying to invent construction robots for building space colonizations. They're also developing spacecraft with a nuclear-enabled propulsion system, and also inflatable heat shield to land astronauts on different planets. They're also proposing high-tech space suits, which they call right now exploration extravehicular mobility unit, as has like a semi gravity to make people like move less harder. There will be advanced 3D printers. They will embed Martian home and vehicle as a single rover. They are also trying to propose laser communications and nuclear fission power system concept for uninterrupted power on different planets. This is the Martian home, the construction robots, etc. And this is an example on the laser communication. And finally, the last two space future technologies. The laser, it can drill into the regolith of Moon, Mars, and others and convert it into oxygen, drinkable water, and other products to support humans and plant life, to secure consumable and fuel resources. And there is the delayed disruption tolerant networking. It is basically a reliable solar system, internet connection for space missions with automated efficient data delivery between providers, like no matter how the distortions, the distance, it will provide the data efficiently. This is a picture of the laser and they propose the answer. Thank you so much for listening. I hope that I inspire you guys to get more involved in this industry, and I wish you all the best. Thank you.
Thank you so much. Really appreciate that. I don't know about you, but my mind is a little bit blown with all those various ideas. A space hotel. I'm not sure. How many of you would like to go to a space hotel? Oh, quite a few. Okay. How many of you can afford to pay for going to a space hotel? Yeah, that's a bit of a problem. So where we are. We go back to our question. We have, how do we balance our desire to explore space? And there's no question we have this incredible desire to do unbelievable things in space, but how do we balance that with our need to resolve the issues on Earth? And so, you know, we saw all kinds of incredible things. $55 million to go on a, was it 3 or 4 day orbital mission? 3 days, yeah. $55 million. How many of you can afford that? No. But it does bring into question, you know, what else could we do with $55 million times 3 or 4 for the number of people on the flight? You know, the amount of money that's spent just on space tourism could do all kinds of incredible good on the Earth, and we know that we have all kinds of problems and challenges to deal with, whether it's climate change, whether it's poverty, food security, all kinds of other issues. So the question is really around balancing that desire, the costs, benefits, risks, and so on. So let's think a little bit about that and what let's pick something, because I think we're going to go through a process that I think we need to explain. I have to find the. There we go.
Well, we are coming to the most interactive part of our today event, and let's go through the agenda. So today the first part will be with the discussion. We will discuss different examples of and ideas of space exploration, and then we will analyze what are the benefits and risks of these ideas and propose some actions. Then we will move to the presentation part. We will invite you to prepare your presentation. You should have these big pieces of paper, and markers, so you can summarize all your ideas and make a poster but please leave a couple of space there, because after you will have an opportunity to add some new ideas to your poster. When? Well, then we will invite you to present your ideas. Each round table, each team will be invited to present ideas. But not all of you will do it. We will invite you to select 2 presenters, and other participants, other team members will be invited to visit our other round tables and collect new good ideas. Then you will have time to update your presentation and make a final report.
Great. So just to review, you're going to discuss, you're going to come up with ideas. We've got some forms there for you. I think we've got some things. Yes, so you're going to identify some examples as part of the first part, identify some benefits and risks, and propose possible actions and choose somebody from the team to take notes. So the timing is probably going to be compressed a little bit because we're running a little bit behind, but then you'll prepare a poster presentation. So.
Yeah, if you want, we can brainstorm some examples.
So, Ksenia, if you if you were thinking of identifying an example, so what's an example of something that you might pick?
Well, we heard a wonderful presentation by Jorge and Reem, and I think a good example, the good idea could be to colonize Mars in future.
Wow, colonizing Mars is a great idea, but if you think about it, there are huge benefits and risks associated with that. What might be some of the benefits?
Well, one of the benefits could be to obtain a good place to escape. In the case if we have a real serious problem on Earth, we can save the human race. And what could be the risks of this example?
I guess we've made a total mess of things here on the Earth. We could, we could send a few people to Mars and start over. But in terms of the risks, we know that traveling in space for that amount of time to get to Mars, there's radiation risks and all kinds of other risks. Perhaps the equipment failure, the whole thing could end in a disaster. And then, of course, there's the cost. So all kinds of risks as well.
So what we propose to you, after identifying benefits and risk, you could discuss and propose possible actions that could minimize risks and raise the benefits of your idea. Well, you can come up with other ideas. So what we heard today, like to construct several space stations and launch them around the Earth, to develop space tourism, and so on. So you can give your own example. Is it clear to you? Great. So
we've provided you with some worksheets on the table that look like this. So it gives you a place to write your examples and then the benefits, the risks, and the actions. And if we go back, we'll spend the first little part just focusing on identifying some examples. And so do that first, and we'll let you do that for 5 to 10 minutes, and then we'll ask you to switch over to benefits and risks. So get started. So remember that your focus right now is on identifying examples. In about 2 minutes, we'll ask you to switch to identifying benefits and risks. I know that some of you have moved on from that and you're doing it all at the same time. That's okay too. We just want to make sure that you get through the whole process. Okay, you got about 2 minutes left in the identify benefits and risks stage, so you should be doing a good job of identifying some benefits and risks at this point and getting ready to move on to proposing possible actions and choosing somebody from the team to take notes. Okay, we're now at the third stage, so you should be working on proposing possible actions and at the same time choosing somebody to take notes from the team. Although from the teams I've looked at, it looks like everybody's taking notes, so I don't think we have a problem there. But move on to proposing possible actions. 2 minutes left to wrap up your proposing actions and to move into the fun part, which is to get your poster ready. So in about 2 minutes, you should be starting to prepare your poster that you'll present to the other groups.
Dear friends, dear participants, so we are coming to the last stage of the discussion. We invite you to start to prepare your posters. Please use the big pieces of paper and your markers and try to summarize all your proposals, all the best proposals that you have, but please leave a little bit space there. Then you will have a chance to add some new ideas from other groups. Let's start. You have 15 minutes. If you have a lot of ideas, many ideas, try to select the best of them, the ideas that you all agree on.
Okay, just to be clear, you should be working on your own group's posters right now, not visiting anybody else yet. The visiting happens a little bit later, so work on your own group's posters right now. And you should be started on your poster. You only have 15 minutes to work to prepare the poster. have about 5 minutes to finish your posters. 5 minutes to finish your posters. You have 2 minutes to finish your posters. 2 minutes to finish preparing your posters. Okay, I'm going to ask you to take a seat, sit down, so that everyone hears all the instructions. So everybody just sit down at your table. And I will explain the next section. So if we can have everyone sitting down. I'm going to explain all that. So everybody sit down first so that we hear the instructions, including this group at the front here. Thanks so much. Okay. For the next part, here's what you have to do. Each group needs to select 2 presenters. So 2 people will stay at your table to present your poster and present the ideas. If I could have your attention, please. Excuse me, folks. That's a little bit better. Excuse me. Thanks. Okay. So, you need to choose 2 people from your group to stay at the table and present your ideas. The rest of your table, you need to divide into 3 groups. It could be 1 person or 2 people in each group. That's fine. Those groups are going to go visiting other tables. So you have 2 presenters. The rest of your table are visitors, and they will go and visit other tables. In the next 15 minutes, they will visit 3 tables. Doesn't matter which ones. And the idea is to go, hear the presentations, and gather new ideas. Ideas that are new and different that you think are interesting. The visitors will come back to the table after 15 minutes. You'll have a few minutes, about 5 to 10 minutes, to add some new ideas to your poster. And then we'll ask you to, if you can, to record a video of your presentation with all the ideas that your group has gathered, and no more than 2 minutes in that video.
And please pay attention. At your table you must find a sheet of paper with 2 columns, the new ideas and the ideas similar to ideas that your team had. Yeah, did you find it? So visitors, please take with you this sheet of papers, and please make notes there. So then you will come back to your team with the new best ideas that you will propose to introduce, to add to your poster. Is it clear?
Okay, so we are going to start the visitation very shortly. So you should have 2 presenters. Divide your visitors into 3. They will go visiting, and we will start in about 1 minute. Okay, let the presentations begin so the visitors can get up and go visiting, and we should have presentations going on. Keep your presentations to 2 or 3 minutes. Keep them quite short. So your visitors should be visiting now. Presenters should be presenting. And just a reminder that your presentations take place at your table. So you should have 2 people presenting your poster at your table. The visitors go visiting other tables. Or they can just gather around whatever works.
about posters? What we will do with posters? Let me check. Let's move the slide. Now, very soon. In 10, yeah. Dear friends, may I have your attention? Well, thank you for active participation. Some of you...
If we could have your attention, please. We need to be very careful about the time because we have some buses leaving that you need to be on. So we need you to pay attention. We only have about 3 minutes.
Yeah,
So
the presentation part is over now. Some of you practice it in presenting your proposal to different audience, to different people, and some of you gathered some new ideas from other teams. So that's really good.
So
now
you should return to your table. Return to the table that you started at now.
and communicate the best ideas that you've learned at other tables. Please communicate the best ideas, and if team agree, add these ideas to your poster.
And you have about 2 minutes to do that. And then we will finish up. Okay, you should be adding those last new ideas to your poster. We are going to make arrangements for you to film the videos tomorrow.
Now we have no time. We will explain you when you will film it.
So you don't need to try to record your video right now. You'll be able to record it tomorrow. We'll give you the details on that in a moment.
Hello guys, can you please sit down? And it's very
If we could
important
have
that
everybody
you
sitting down now, please. Thank you.
sit down, because I need to give important instructions. You have to leave
Yeah.
for the city tours. If not, you are going to lose your tour. So please here, listen. Silence, please.
Everybody, please. If you
Thank
could be
you.
sitting down for the instructions.
Thank you.
Thank you, because
Okay,
we want everybody on the tours.
Sorry, Rennie. The most important part now is to get the your proposals, because we need to record them. As we don't have time because you are leaving for the tours, tomorrow after lunch we are going to meet here again, okay? So from 2 to 5 you have a space to rehearse for the cultural evening. We will take only 15 minutes from your time to record the video of your presentation, and for you to take some notes and some things that we need you to register on a report. So if you agree, we will meet tomorrow after lunch at 2 o'clock. Lunch finishes at 2. So at 2, we meet here in this room, okay? Clear for everybody?
Hang on just a sec before you run away. First of all, I just want to just have a seat for a second. First of all, I just want to thank you for all the incredible work that you have done. It's wonderful to see people from, is it 19 countries?
19.
From 19 different countries working together, collaborating around a table to solve and work on ideas to solve a problem. So thank you for your work. We will see you again tomorrow at 2 o'clock. Ksenia?
Yes, thank you very much for your active participation and collaboration. Now you realize that no scientific work, no other work in the today world is possible without teamwork and collaboration. So we invite you to proceed and come here tomorrow after lunch and film a short video, no more than 2 minutes, and send it to Liz, to your WhatsApp group.
We'll be here tomorrow.
You can leave
2
your
o'clock.
posters on your table, and just please put the number of your table in a corner on the poster, just to not lose it, okay? I am going to keep the posters.
There we go. Thanks very much and enjoy your
Thank
tours.
you. Bye-bye. See you tomorrow.